This is the exact moment your coffee turns bitter. And unless you've seen it under a microscope, you've never actually seen it happen. But here's the strange part. The bean itself was never bitter to begin with. Somewhere between this bean and the coffee in your cup, something goes very wrong. To find the answer, we need to go inside the bean itself, because hidden in here is a trap built by fire. Before roasting, a coffee bean is surprisingly dense. Its cells are packed tightly together. Almost nothing can escape. Then heat enters the bean. Water trapped inside starts expanding, and pressure begins building everywhere at once. And then it happens. The bean begins tearing itself apart from the inside, not destroying itself, transforming itself. What roasting creates isn't flavor, it's architecture. Millions of microscopic chambers connected by tiny tunnels. And every wall is coated with something valuable: sugars, acids, aromas, and eventually, the bitter compounds. And the moment hot water arrives, the extraction begins. The question is no longer what the bean contains, it's what the water finds first. The first compounds to leave the bean are usually the easiest to reach, the brightest flavors, the most delicate aromas, the ones we often describe as sweet. At first, everything seems perfect. The water finds the flavors we want and leaves much of the rest behind. But deeper inside the bean, another layer is waiting, and those compounds are much harder to reach. This is where bitterness begins entering the cup. Not because something went wrong, because extraction kept going. The same water that carries sweetness eventually carries bitterness too, and it can't tell the difference. By this point, many of the best flavors are already gone. The water keeps searching anyway, and what's left isn't always pleasant. And here's the part most people never see. Bitterness isn't added at the end. It was hiding there from the beginning. The bean isn't releasing flavors in categories. It's releasing them in order. And bitterness simply arrives later. So if bitterness comes later, then one question changes everything. How far should extraction go? By now, most of the sweetness is already gone. But the water doesn't know that. It keeps extracting whatever it can reach. And what's left is very different from what came out first. The deeper the extraction goes, the harsher the flavors become. This is the difference between balanced extraction and over-extraction. The same bean, the same water, a completely different result. At some point, the water stops collecting great flavors and starts collecting whatever is left. And that's why bitterness isn't coming from one place. It's coming from thousands of microscopic extractions happening at the same time. But here's the part that surprises most people. Bitterness isn't the enemy. Too much bitterness is. A great cup of coffee needs bitterness. Without it, the flavor feels flat. The secret is balance. The best coffee isn't extracted completely. It's extracted just enough. And that's the trap. The longer you extract, the easier it becomes to chase flavors you never wanted. So if bitterness is simply the final stage of extraction, why does adding milk change everything? If bitterness comes from compounds dissolved in the coffee, then milk shouldn't change anything, but somehow it does. Most people think milk simply dilutes the coffee, but that's only part of the story. Because milk contains proteins, and those proteins start interacting with the compounds responsible for bitterness. Not removing them, not destroying them, just making them less available to your taste receptors. The bitterness is still there, but your brain receives less of it, and the balance shifts. That's why the same coffee can taste completely different, even when nothing inside the bean has changed. The bean hasn't changed. The extraction hasn't changed. Only the way your senses experience it. And that raises an even bigger question. If flavor can change this much after brewing, what is taste actually measuring? The strange thing is, bitterness isn't actually inside the coffee. Not in the way most people imagine. Inside the coffee are only molecules, moving, colliding, drifting through the liquid. Taste begins only when those molecules meet you. Without that interaction, bitterness doesn't exist at all. What we call flavor is really a conversation between chemistry, physics, and perception. And all of it starts inside a tiny roasted bean, smaller than your fingernail, yet complex enough to fool your senses. We've spent this entire video chasing flavor, but next time, we're chasing color. Because this bubble is made from one transparent film, one surface, one material. So why does it show every color? And hidden inside those colors is one of the strangest tricks light has ever invented.